have some preparation of some kind of like modules that I have written already for you, so you can test those ones, and I have posted on the module for tonight. They're both for the format methods, which is a general purpose formatting for formatting strings. So whenever you do formatting strings in Python, whether it's file IO or just regular text files, you're using the format method. If it's older version, 2.7 or 3 or 3 and up. So the format is backward compatible with Python 2.7 also. But the fs string, which is for Python 3.5 and up, is a new function which is called fstring function or fstring statement. This fstring is supported only if you're running Python 3.5 and up, which is similar to the format method, but it's a lot more kind of enhanced, a lot of easier to write the code and easier to modify it, update it with less amount of cryptic coding. Format is not hard either. It is a little bit kind of like tedious to write it, but it does serve the purpose in either case. Compared to fstring, when I say tedious, fstring is much easier to write because you could use the combination of options that are there in a much easier way by putting it into the placeholder where you're writing it rather than just using the format with passing arguments to it differently. So we will discuss that one. And this is like right here are the examples with both of them. The format.py is one of them that I'm going to walk you through all of this. But in order to do that one, I'll open up a kind of Atom or PyCharm or idle or interactive session so I can walk you through the steps by steps in a session. Here, and then this is there, so you can cut and paste the actual script. And then here I'm running the output of it there. You can cut and paste from this screen, and then you could practice it yourself at the laptop if you want to do that one. This is my fstring, the first one that shows the fstring in comparison to the format. And again, for each of these examples, I'll walk you through. I will modify. I'll point out to each line what they mean and what they are, and so on. So the fstring is there. Couple of examples. One is my fstring, and then the other one is my fstring 2. A second example, and then a third example, my fstring 3. And then with the format, we will see the output as well for each one of them. Let me just open up example here, and we're on Windows here. You can do the same kind of functionality on both platforms. In fact, I have Windows, the version of Python here that you can see is Python 3.8.3, and then the Unix machine Python-V is showing 2.7 unless I run Python 3. So this is on Unix machine. This one is a Solaris Unix machine. As you saw that last time when we did cut etc OS release, it says Solaris 11.4, and the latest Solaris version, it's running up on this virtual machine. But what we could do is to show you the format on different platforms to show you, for example, when I say that fstring is not supported in Python 3, then I could demonstrate that one as well here. But on Windows, since I have only one version, let me change this screen here and then move this one up here. So right now, I think it's a better screen here. You can see everything. So on Windows, I type in clear screen to clear the screen. And then here, the directory, I have a directory called Python formatting. So I go to Python formatting. If I type in py*g, meaning that anything that starts with py and then the rest of them asterisk, meaning replace the rest of them up to letter G. Since that is making unique, I could fast type that one and then click here and then click there. I mean, type in there. Now I'm on that directory. So on this directory, I have a number of examples that I could show you. For example, on Windows, I could do a type and then just look at this my format, this one, and to just display. And this one, I'm having first name as a string Wahid, last name Lutfi, title instructor, favorite sport soccer, class title or course title, introduction to programming using Python, and course name is CIS 012, your course. So here I'm using the print statement, but with the format method. So print is also a function, as you can see that we have been using print statement with left parentheses, right parentheses, but inside here, we're using the format. So in this case now, if you want to put these hard-coded variables inside here, you could do within double quote here, those ones. But if you define a variable, you could replace the variable. So when you're using the dot format, and the format method, it takes a string, which is this string, starting with the left parentheses, with the left parentheses with single quote and then double quote. So this single quote and single quote here is basically one string getting with the format method, and these ones are placeholder. So I have 4 placeholder. This one, this one, this one, and this one. So that I have to have 4 parameters when I do format. This placeholder, the first one will be assigned to this, the second will be assigned to this one, and third one would be here, fourth one here. As you can see on the other example, I could just put first name 0, and then last name is placeholder 1. This is also accurate. And then the next one, as you can see, right here, I'm having 2 argument on the format as course name and title. So I say I love teaching, and then the C name will come here, and then C name is CIS 012, and then C title would be replaced to Introduction to Programming using Python here. And then the next one, the example here, you can see that it says in this case, I'm using the number 1 argument. Number 1 argument, because this is a placeholder, this time I'm switching the first placeholder to take the argument of the second argument, which is C title 1. So the course Introduction to Programming using Python is the course CIS 012. This will be replaced because this is the second placeholder has the parameter of 0, which means take the C name as an argument here. And this one is the first one there. So you can switch as long as you just do that one, that's fine. And then between this format functions and the new format function is really nice. I will show you later on the comparison. But here I want to point out, because this is screen is open. So if you want to change this function, for example, this statement to a F string format, the only restriction is that you put an F here in front of the first string, which is the single quote here. You could do a single quote or double quote. As long as you start with a double quote, you have to close it with a double quote, like here. So you could put an F in front of this or F in front of this, and then instead of putting dot format here, you could close it with this right here, with after this single quote with closing it, remove all of that out, and then put this F name inside here, last name inside here, and then title inside here, and then C name right here. And it's much easier to write it that way because you're here you're just putting a placeholder, then you're just using the format. But with FS string, you don't have to do that one. You could just do it there. So if we want to just, since we're inside Python, I could just modify the same thing. Notice this one here, I'm only putting one string for a favorite sport, so I have one placeholder, and I could use 0. Both of these statements will produce the same thing. I could not put 1 or 2 or something because I don't have a second argument or third argument. So that's the argument. So if I want to run this program here in Python, as you know, you could just say Python. It will run it. It will run it, and the output will show right here. Notice that Wahid is on the first one, which is first name, last name is Lutfi. Then it has a comma because right here, whatever you put, it just says that I'm Wahid Lutfi, your instructor for CIS 012. And then and then instructor got replaced with that one, and then 4, and then the course name replaced for here. And then here we are using the same statement, but we are using the placeholder position argument, like 0 for the first one, 1 for the second one, 2 for the third one, and 3 for the. And computer science, arrays and positions always start with 0. So even if you have 4 parameters here, the last parameter would be third because you started with 0. 0, 1, 2, 3, that's 4 arguments. And the same thing with arrays, the same thing with tuples, the same thing with lists. So whenever you're doing slicing, make sure that you consider the first index of the indices, and the first one is always start with 0, and the last one is the length of the indices. So in this case, if I just want to do, let's say Adam, this one, and then open up the my format.py. I want to open up this one in Adam's editor, because Adam, when we installed it, I also installed the plugins for Python modules. At this time, I could execute it with the plugins of modules, and then run it as if it is compiled already or interpreted that way. So let's see if it opens up right now. You can see that this program opens up. And if I just run this one, let's say I just get rid of this one to just for clarity so you can see smaller screen. If I just say run this script, since we did that one, it should give you the same output here as on the command line. And then right here is the output. You can see that it is giving you exactly the same thing for those outputs. So what I want to do is just convert this one to a F string right here. Let's say convert one of them to a F string. So I will show you how easy it is to convert it to a F string. So in this case, I'm going to put the first name here. Sorry, I have to be on this line. First name here, and then last name here, and then title here, and then course name here. And as I told you, you don't need these information anymore. This information is extra. So I'm going to get rid of all these statements starting from here to until the dot. And then put this bracket to close the F string. But right now, my print statement is not going to recognize that one because this is just a regular print statement. And then when I do this one, and watch if I run it here, save it. and then run it, and it's going to just do write those characters as if it is not understood the value of it for placeholder to replace it with the actual value. And the reason is this one, because that print statement is just going to print it exactly of what this is. So in order to make that code, the F string is the one you want to use. So you put a F here and then just run it, save it first, save it and then run it. Sorry, run it here. Notice that it just changed and now this is the same thing. So if I just put something here, say, I could print something again, like another title that I didn't write here. Let's say I want to say see title on this one to tell you that in this one, as long as I could put a word for and then see title for introduction to programming. So, and then put a dot here and then save it. Now my F string is much easier to write in comparison to the format, but if I run this code, it gives me exactly like here in the introduction and all that lines. So notice how simple it is. Are you using the F? If I use double quote here, I have to do the double quote here as well. If I do it without it, it's going to give me a traceback error. So if I start with double quote here and then close it with single quote, it would be a problem, as you know. So that line is giving me saying that I started with double quote here, so end of line while scanning string literals. So it did not understood that one. I need to double quote it here, and then save it, and then run it, and now it should work. As you can see, it does work because the F string. It is, so whether you use single quote or double quote, that's your choice. But when you start with a single quote, with the print statement, with F string statement, with R string, any of them, when you start, you have to close it. In case if you want to say, for example, the title, you want to put around it a single quote, this still works because what it is, this one is double quote here. So let me save it. And then you can see the title is having quotation around it with single quote around it. So right here you can see actually for the, let's see, this one is there. I am, so on the title, yeah, the title got updated, but I meant to do not the title, double quote, and I wanted to do the C title, which is the introduction to programming using Python. So when you do that one, and notice that the editorial, as soon as I put one single, it puts the other one for me as if like, oh, inside of it, I want to put a string. So you have to correct that one when you do it. Sometimes editorials are not too smart when they're acting like doing the work for you. So and if you look at this one, introduction to programming, now it's a single quote. What if I just change this one to double quote? If I do double quote this one, then it will break my code because what it does, it says, okay, I started with this double quote and I ended here. Then it says, oh, I don't understand this part. So look at this. If I just run it here, save it, and then run it. Most of you might be already aware of this, but what you do is, in this case, since you use double quote there, outside you have to use single quote. So then you close this outside. So outside is single quote, inside is double quote, or outside is double quote, inside is single quote. That's how it allows you. You cannot do both of them there because it does not know where it starts and where it ends. Now it's going to work, and because we change it, and notice that double quote around it right here. So that is the example, the first example what we did. Do you have any question on the first example? Okay, if no question, I'm going to open up the second one. So let me save this one and then open up my open file. And then my F string. And then the thing that was on my format, this is not like restricting you to just put only a string. You could put any number, age or difference, floating point numbers and the calculation. You could do many other statements. Let me just do a couple of calculation. Like for example, if I just say right here, I could say import math. And then I could come in here, say, on the first statement, let's say, and then say something like, instead of doing this, let's just generate math formula. For example, the result is equal, let's say, we say, let's say we just say, I could do a number of things. Let me do first say math.pow. We're gonna just do a couple of things. So a square root of a number. We could call it a square root of a number, and then we say math dot square root of 100, which is 10. We could do that one, and then we store it there, and then we also do a calculation inside, and we could also do some other values. So for example, let's do some numbers. And inside here, I'm going to say the format statement. I could say the square root of the percentage num is and then we could just say format and then put num here and then put a square root here. Let's just do that. A simple example, square number. And then here is, and then we could just say this. Since it's the format function, we could do something like this just to do the format. And then we could do the same thing for this and then use the F string. We do a F here and then we put num here and then here we put the square root, a square number, a square root of the number. Let's just change that one to a square root and a square root of the number. A square root of the number, we change this one to square root of the number and we put a square root of the number and then let's say num is equal 100 and then we just change here to num. So this takes the num and then the result comes here, but then later on we're using the format method to print each one of them as placeholder, and then here we're using it directly with this. So let's just save it and then print run it. Notice that it shows that the square root of 10 is 100 is 10 and right here is 110. So we did see that it's working. But now if we don't do the calculation here, can we just do the calculation inside here? So yes, you can. You could just do the same statement here and then you could say that 2 to the power of 2 to, let's say we say 2 to the power of 10 is, we could just say right here, we could just calculate it as one placeholder, and then right here on the format we could say math.pow for power 2 comma 10. So this argument is passed into this and it will print it. And then instead of this, let me just make it a f function or f string, control C and then control V. We could just say to the power of this, and then instead of putting it outside here, we could put 2 to the power of 10 like that, and then close this thing here. So notice how simple you could accomplish on either case. This was for the square root and this is for the other one. And then the only difference is that here we did the calculation, here we put it into variables, num and then srn, we used it. Here we're doing the calculation inside the format method. So one method, an object-oriented programming, one method could take other objects which are other methods, and this method, math module, has a method pow, which has 2 arguments, 2 and 10. 2 to the power of 10, that's what it means. X is the first argument is 2, and the second argument is 10, and the second argument is to the power, raised to the power of that. So if I save it, I should get 1024 for 2 to the power of 10. Let's see if that is coming. Yeah, right here. And then notice that this one, it just says exactly as the numbers. So something I missed it. Let's see what is happening here. 2 to the power of 10 is, and then it says math.power of 2 to the power of 10. Even though I used it as a placeholder, it did not replace it. For some reason, it did not understood that one. But let's see if we could put this one as a calculation argument to say, go ahead, do it, and see it if it opens up like a shell scripting kind of thing as a subshell. And unfortunately, it doesn't do it that way. So what you could do in this case is just, instead of doing this, you could just say, move this one to make sure this one works. You could just say m is equal, and then place that one to m, and then just replace the character and the placeholder to the value of m. So now math.pow of 2 to the power of 10 is going to be that. Then you just place it. So let's save it. It still didn't do it. So let me see what's going on here. 2 to the power of 10 is m. Power of 2 to the power of 10. Print m. I want to see if m has the value. Oh, sorry. I've been missing the if statement here. So that's a very common thing. So I thought that I put the if there. Here I put it, but here I didn't put it. That's gonna do it. So I don't have to print if. That was a typo here. I thought that I did already. So it was missed there. And the if statement would have not worked that way. So now it works 1024. I don't need to put it into that, and that should still work here, similar to the format. And this thing, I could just change it and save it and run it. Run a script, it is working fine. As you can see, the 1024. Do you have any question on this so far? Okay, I see there are 10 students with me, everyone is 10, so we have 9 people. hopefully the other 4 people will join in so we can start off on the midterm soon, maybe around 8:30. So it's 7:33. Let me go to the next example, which is, I'll save this one. And the next example is the actual F string. And then also from the command line, whether you're on Linux or Windows, I'm sorry, Windows or Linux. So right here, if I go on Python, I create, say, name is equal Wahid, and then import math, and then say m is equal math dot power 2 to the power of 5, which is 32. M is giving me 32. I could do a number of ways I could print this thing with the print statement. So I could say print M, that would give me 32. Or I could say print and then formatted a string and then do this and then do that and then put this one M as a placeholder. That would be the F string, and then I still do it. But notice what inside the F statement, I have controls over here. Whether I'm using the format or F string, both of them has these control characters. So I could indent it differently, put that M32. So now notice that 32, if I want to put some zeros in front of it, let's say I put 10 zeros with 32.0 all together, then I could do that. In front of it, I put about 8 zeros plus 32.0. So if I want to put 5 of them, I could control it. So with combined characters are 5. So imagine if I do this one with 2, that's not going to put any zeros in there because this is only 4 characters. So I have to have at least 5 digit in order to put a 0 in front of it. If I put 2 zeros in front of it, that's 6, and so on. So if I do 16, now obviously 10 more digits in front of it. That is how you will shift the value to with number of zeros in front of it. But you can also do, and instead of putting 0, you could also do this greater sign, meaning shift it to the right. Notice this, this is shifted that many elements. If I put it to 10 elements, then it's going to be shifted 10 elements to the right. And then if I want to shift it to the left, that many elements, since it is already that, let me just put some word here and then say something like, this is a test, and then print this one. Now, if I shift this one 10 digit to the left, it does not make sense because that there's nothing in front of it. But if I have something here, say this is a test that Wahid is working on now, you could see that one now. By changing this one to 5 elements, you can see that this is pushed 5 elements from that to the left. If I do 20 elements to the from that many elements is moved this number. And if I want to do it 20 elements to this, now this is moved 20 elements from the last one to the right. And if I want to center it 20 elements between them, and instead of the greater sign, I use the anchor, meaning center. So this is 20 character between this and last 20 character. If I want to do it 10 characters, I could do that. This is formatting. So sometimes when you're using the multiplication tables and other ones, these are good examples of how you could format it. Again, this is also true about the print with format method. So let me change this one to a format method. And instead of this, let's say I have a placeholder here. And then instead here, I'm going to say dot format. And inside here, I'm going to put M, and then M is my value. So that is my format. And then there's no other argument to it. So let me say format, and then right here I single coded, that's fine. So right here now, I'm not going to put this M here, because that M is going to replace on the first argument here. But then this one says, once you have it, now you format it that way. Notice that is okay there. And then if I want to just do the shift it to the right, it is done. If it's shifted to the left, is done. So now since the 32, if I just changed M is equal, let's say digit is 10, is that. And then I want to print that one to the 10. Now 10 is printed. I want to print this one in floating point value. So I could put this dot F, that would, sorry, I could put F, and that would just put 6 floating points after it. But if I want to do only 2-digit floating point, then I have to do dot 2F. That would put this one. If I wanted 3 of them, again, this number just changes, and then that puts exactly there. So if I want to change this one, and then I want to get, instead of floating point numbers, I want to get binary numbers. So notice that 10 is equal 10, 10. And then if I wanted an hexadecimal value, then I get the X value for it, and that's A. And then if I want to do it octal value for it, you just do O. Notice that X, it was uppercase X, and O and B for binary and octal is different there. So you could produce that one. I'll show you more examples of it. Whether you use the format or FS string, it's okay. But the reason that you want to stay away from the FS string in general is because you might be working on Python 2.7. So right here on my Linux machine, the default Python version is 2.7.14. And then Python 3 is the version that is 3.5. So if I go to Python by default, notice I'm on 2.17. So if I declare a variable called x is equal 5, and then I want to print that one in FS string, it's not going to work, because what it is saying that, okay, this x, the F method is not defined. Right here, and I want to just show you that part only, and then let's see the difference. Now it says FS string is not defined, invalid syntax, because I'm on Python 2.17. So let me just exit out of this and go to Python 3. Now I'm on Python 3. And this, I cut and paste exact statement here, and then I put it there. Now, sorry, because of indentation, it moved there. So X is defined now, and then the print exact statement of X this time would work, because that one is invalid syntax. Let me see. F print, oh, print, and then F string. .6. I think it is version 3.5. It might be 3.5.6, the subversion, not 0.3, because this one is a little bit older version. Let me log into another version, because this one would work here. Just to test that, x is equal 5, and then we say print f, and then single quote, and then x, and then close it. That would work. So it is because this one is version 3.8.5. So Python, this is 3.8. The one version, this one is 3.5.3. I believe the version that we want to use is 3.5.6. Let me double check that one. Bitwise, if I go to another session of on my Linux machine, I might have later than 3.5. I want to test that one. So let me connect to a Linux machine. Okay, so this Linux machine here I'm using is a uname-a cat etc os-release. This is Ubuntu 19.3, and then if I look at this screen of this one, Python-V, this is 3.6. So even though 3.5.3 does not work, 3.5.6 may work. And as an example, if we use 3.6, which is close to the 3.5.6, it might work. So let me go to Python, and then x is equal 5, and then say print f string, and then we use the brace x, and then close it, and then do that, and that works. So if I want to print it in maybe with some floating points numbers, some binary of f, I'm sorry, not d, for a binary, then you will get 101, which is accurate, and then x values is accurate with 5, and then octal is also 5. So if I just go ahead, do it, notice that 3.5.3 was not compatible. That means that you can use the format with that method here, and it would work. So everything here that it gives syntax error for this, let's just make this screen a little bit bigger. So this one was saying that this is print x is going to work, but if I want to do that f string, this one would not work. So let me just do the format of that one. I'm going to take the f out here. I'm going to take this one out here. I'm going to put a dot format, and then I put x here as the format, and that would work. And then if I want to just format it differently, I could just say, put it into, let's say, move it to the right 10 digit, it will just shift it there. If I want to just do something as put zeros, 10 of them in front of him, I could modify it with that format. And if I want to get the 5 in binary, then I could just do that too. And then x now, if we just say 15, which is hexadecimal, would be f. If you do this one and then print the hexadecimal of it, you could see you get the letter f. If you just do the octal value, obviously it's a different number, and then that's 17. So because oct is base 8, octal 7 actually, and then binary is 2 and hexadecimal 16. 0 through 8 is actually in base 8, but it is because it starts with 0. So the other one, hexadecimal, is base 16, but the last one is F, A being 10 and B 11 and until F15, and then 0 through 15. So here I have another program I could show you that one. So F string here, we did my F string here, and that shows exactly, let me just run this, save it, and then print it, run it. In this example, we're basically creating this structure with strings, and then we're printing it with f string. As you can see, the f string is much easier to write. But because we are using Python 3.8 on Windows, it's no problem. You have to have Python 3.5.6 or later, and normally when you're using the f string. So let's just do be safe, say run it on Python 3.6 or later, just to make sure it's compatible with it. But if you're using prior to version like 2.17 or maybe 3.5.3, then use the format in the state. So let's just open up another one here. This is my string 2. I'm going to open a file. In this example, basically, I'm creating 1 kilobyte as a 1024. Then I make 1 megabyte. 1 megabyte is a kilobyte times a kilobyte. The same thing with a gigabyte, a megabyte times 1 megabyte. The same thing with terabyte. So you do the calculation here, then you print them afterward. And then notice that the print statement, I'm doing different kind of examples with the F string. With the format, you could have done the same thing, but it's much easier to write it here than the more format and passing all arguments to it. Here, you can see 1 kilobyte is, if I run it, let me just run it. And then notice that here, when we're printing it, I'm just like printing the 1 kilobyte first and then 1 kilobyte. If you don't put any floating points from the dot after, by default it puts 6 zeros to the right. And if you just say dot 2f, it will just put 2 digit after the dot as a floating point. 3 as would be doing 3. Here I'm putting 10 zeros with the character, whatever is 1024, so it's 4 digit, then I do 6 zeros in front of it. Here I'm going to do 20 digit, so 4 plus 16 zeros in front of it. The next one, I'm moving it to the right 10 columns. So 6 spaces, if you want to put the spaces in front of it plus 1024, then you say the 6. And then this one, 6 space to the left. And the left of what? The left of the last character. Here the dot is the last character, so shift it to 6. This one is centered. So you could center it 10 digit. And if you do the same thing with left and right, and greater sign is meaning to the right, left sign is to the left, and then a less than sign is to the left, and core is to the center. So now I could also use the placeholder and actually put the variables there and then do that one. And then here I'm doing the calculation also. So I don't have to do on the top, I could do inside the placeholders, and that would also do it, which we already used some other examples earlier. So if I go back on the bottom, you can see that it's there. But because these numbers are there are really huge, in Python you can always put comma to just put the 3-digit difference when you're printing it there. So you could just say, for example, one of the numbers is really huge, right here, 1 terabyte. I could put colon, let me move it to the right here so you could see the screen better. Right here, I could put a colon and then put a comma here, meaning that once you print it, separated by spaces. So that formatting is also available as an option that you could print it differently. Let's see. you can see that in comparison to the other one, which was really long, this one is separated by comma. So right here, if I do the same thing here by colon and then comma, this statement also will be more readable. In order to make it readable, Python allows you to do that one. So a script and then run a script and then do that. Notice that it's now much easier to read because you can see. Another technique that Python allows you, for example, you have a 1 million, and so 1 million, let's say 1 million is defined, 1 million is defined as 1 with 6 zeros. And let me see, okay, 1, 2, 3. Can't even type it because sometimes instructors and unfortunately, with the way economy is, most of the instructors will never see the 1 millions there, but only millionaires are getting billionaire, so much easier for them to type in. In that case, if you look at it, 1 million here, you put underscore, that is automatically Python is going to allow you there. So if I just have another 0, 1 billion, and I want to just print that one, say print 1 million, I don't have to use the if statement. I could do that one here and then save it. So this is 1 billion, right? 9 digit. And then if I do 9 digit zeros and then run it, let me see what happened here. Oh, 1 million and then let's see. I'm going to try this one first as this, and then somehow it should read underscore, and then you can even do calculation with underscore and run it. Yeah, so it did understand, and the first one, let me see, 1 million is printed here, but I want to print this one with F method, F a string, and then do this one as a placeholder, and then I put the colon, and then I put comma here, and then do that. Let's see if now it breaks it for me easier this way. Okay, so in the while statement, oh yeah, I forgot to put this code around it here. That makes sense, so let's save it. And then run it. So that would work. What happened here? Not found. Package, script, run. Yeah. So now you have commas separated here. But let's see if we define it here with underscore. Would that work or not? Because it should work there, unless it's the editorial Adam is getting confused. No, it's not. So it does say that one. For some reason, when I did 1 billion, I was not getting it. Let's see it. It should work the same way. Save and print, run. Yeah, it works. Let's just do this one without the F string. I think it was having a problem with printing it with F string, without the F string. So if I just want to print it regularly like this, it should also give me 1 million in the sense that it prints it, the print statement should print it. Earlier it was having a problem. Maybe I had a different, yeah, I must have written different things. So here, you cannot put a comma there. It would mean nothing here because it's a space there. So that this syntax is much more cleaner in terms of how you want to see it. If you want it with underscore, then you cannot put underscore here to format it that way. But as separate with comma as a separator, it's accurately defined. If I put underscore here, it may not understand it because the f string argument may not be handling it. Yes, it actually does. So that is good. I was just thinking, but I didn't read it in the documentation or anything. It might be in the documentation. Maybe I did not find it when I was looking at it, but it does support you to do the type of format with f string as a separator. So now you can see 1 billion is printed that way. So let's save this one and then open up the last one. Let me see on 7:59. That's perfect timing in terms of the next one will be the last one we cover. Do you have any question for anything so far? Okay. Python, my Python string does. Nobody is looking at the midterm yet, right? Because it's not open till 8:30. Is that correct?
Correct. I did have a question, Professor.
Thank you. Go ahead.
Reading formats is that going to be on the midterm, or just everything before today?
The string and the format. What I'm covering today, no, it's not. But it might be on the final. The final, I'm dedicating more on the what we cover moving forward. But chapter 1 through chapter 10, when we covered it up to tuple, they are in the midterm. So for each of the question we have, starting with a variable declaration for chapter 1 or a statement, and then let's say we covered if a statement, for statement, while statement, tuple, list, data dictionary, and then we also covered less comprehension. So for each one of them, there's a small question. One question may have 2 or 3 sub-questions, but they're so simple, so easy. Some of you might kind of like laugh at the question, say, oh, this is so a piece of cake for me. I could just handle it right away. But don't bet on it because at the last few questions, there's a little bit tricks on it to make sure that there's a difference between an A student and a B student, and you could do the submission correctly. So there has to be some judgment on in terms of how you do this coding. And I'm not gonna kind of discredit you if you do it a simple way or kind of like a method of answer the question right. That is still right for the answer, but don't think of like writing something that it's repeated 10 times when you could write one line to do the less comprehension, for example. So something that is as easy as writing a list comprehension or creating the tuples with the for statement to do one for statement. You don't want to put 10 print a statement, say print this, print this, print this, when I'm asking to say, define this. Let's say I have this tuple here. I say, how would you do a print a statement and then look for a certain string in it, like hexadecimal or octal or something. If I'm looking at that one, then you're putting a for statement, and inside your for statement, you say f octal is in that tuple, then do something with it. those kind of things you will have to write it the way the question is asking. And if you need any clarification, read the question again. It's much, much simpler than just somebody explaining to you that how you would do it. And then I'll walk you through the questions before we just start the midterm. So let me go with the rest of this. Any other question?
Oh, that's great. Thank you.
Okay, thank you, Rosalinda. Rosalinda, right? Rosalinda.
Rosalinda, yes.
Thank you, Rosalinda. So this one, on this example, we're creating a tuple, which is called my tuple. And then we're putting decimal values, floating points, binary, octal. And then notice on this one, we could make the program more dynamic. So let me just get rid of some of these ones. I did this F binary statements already with the other example, so I don't need to have this line here. And then here I'm creating a max, and then max right here is I want to just say for all the numbers between 0 to 128, which is 2 to the power of 8, would give you all the decimal numbers, 0 to 128, floating point numbers, binary, octal, and hexadecimal. I want to print out the list of them. So let me just run it to show you the output first before we talk the rest of this. I'm going to do a save and then print on this. And then the output is going to show here. So let just save and then print. Why didn't it give output? So this one says finished, but I don't see the output. Let me see why. If max is equal 0, so the max is there. This if statement, I could put a while statement to check it. I don't need to look at that one at this time, but let me try to run the same program from this, see what's going on here. So clear screen directory, and then the name is this one, my string 3. So I want to run that one with Python, and that works. So the reason it is on Adams, it might be just doing it because it got confused with which one I'm running. Let's see, my string 3, I'm going to close these other ones and then go to the top here and save it and run it again. Yeah, so it does, because of the other ones were open, it just kind of like got confused. So let me move it to the right a little bit here, and that way I could go to the top. So this program, as you can see, it prints out a nice formatted values of all the digits from 0 to 128 all the way. And then it also print in binaries. But the binaries, the way I do it is I'm putting it in 2 bytes code information 16. So if it is even 0, I put 15 zeros in front of it. If it is, for example, 1, I put 2 bytes, and the first 8 byte is 0, and so on. So let's just do the comparison of this and then make it a smaller set. So the way the script is written here, if I just want only the first 16, which is 0 through 15, up to hexadecimal A, then I could change the max here and run it. And then now my output is much smaller with 0 through 15. And then notice that the hexadecimal up to 9 is the character, then A and B and C and D and E, F there. Octal is the same thing. Up to 7 is the digits, and then the next octal number is 10, and then just moved up. Binary is this thing. So if I want to just do binary without the zeros in front of it, I could do right here, get rid of this 0. And I could say 2 bytes printed, but in binary, and then center it. So now notice that if I run this one, in the binaries, as you can see, the first one is 0, the next one is 1, this 1, 0 is 2, and then 1, 1 is 3, and so on. You can see this. So if I just change my formatting, notice how nice the formatting is done, and then all this thing is in the right order. So even if I go with a larger number on this, let's say I go to 100, or not 100, let's just make it 1 million. So let's just do that 1 million, the way we did earlier. This one, and see the computation still should carry out, because this one is underscore is automatically knows Python that you mean 1 million, not underscore a number or something. So this is going to run, but because I'm doing it for 1 million, and now notice that this is keep growing. But your code is robust still, because it is not going to break with formatting. Since I'm doing it with 2 bytes long, 2 bytes is enough space on the 2. So if I go with some trillion numbers, the binary numbers is going to go much larger. In that case, then 1 million, notice that it is still doing it. And it is like right here is some numbers. But because Python is interpreter, it is not as fast as C or some other programming languages that are executable that you could create it. But if I create a bytecode out of this and run it in a bytecode, then we could just take advantage of the bytecode of the Python options to just run it more efficient next time with the larger numbers. So right now it is still happening with 257. So it's a quarter of a million already within that much time that it's happening. But if this goes to more digit, obviously, then I need to resize this parameter here in order to make sure my formatting is not breaking. Let me. So right here, this format, the 2 bytes right here that is the prints, I could change this one to 20 spaces in between. That's going to be much larger, or 32, then it's going to go to the right that much is faster. And then watch, I'm going to just do that one for now, because we don't need to wait for another 2-3 minutes for it. It's already at 370,000 there, but we could just change this one to 32, and then let's change this one to 100,000. 100,000. I'm gonna put this 0, and then make this 100,000. That is a little bit faster than the other one, but it's still gonna be taking a little bit time to run. So I'm going to just recompile it again in order to stop the previous one. And then now notice that this one is already happening at the previous one. So I have to actually stop it here. Since I did this one in a package, I could say stop script here, stop script, and then see if it take over. And command line, you could do this one and just do a Control C, and that would do it. So let's just run it from the command line Python, and then this one, because we did it with 100,000, this one is going to be much faster with 100,000. So you can see the numbers are growing, but it is not even 1,000. 100,000 would take a while. So in this case, if I want to stop it here, I could do Control C, and then change the code on this to less than 100,000. So just say 10,000. Even 10,000 is a lot, so let's make it 1,000. Let's make it 1,000. And then by changing this one to 32, it would be too big. I'm going to make it 20, so it fits on the right screen here. And then clear my screen here, and then run this one there. So notice that it is fitting my screen properly, but 20 space is too much space for 1,000. You can see that it is moving it fast, and now at 999 will stop right there, stop. And this is all the format that you want. If I change the same code to say, let's say, do it with 10 digit and different, I mean, your code is much flexible now. You could change this one to put it with 100, and then the format, whatever I put there, I'm fine with the 18, that's fine. So I'm not going to modify that one. If I just clear my screen here and then run the same thing with 100, it's much faster. And then you can see that because of the formatting, it is not necessary to even have 10 spaces here, 10 spaces here, because the digits are only that many characters. So even with 10, it is small. So even with the format, and let's see the format, the way we're using format inside here, I think I need to resize that format also. So I could do with the format of, let's say 12. 12 and 2 character for the space left. Otherwise, if I do 1010, and then that would be a problem in that sense. So clear the screen, run it, and you can see the output here of this. The reason I say that would be a problem because I put 2 space here equal smaller. Otherwise, if I just do exact size of this with the size of this the same, then this is going to be one line. So in other words, right here, what I'm doing on the format on the second statement here, and this one and that one, if it is the size of this 2 bytes, it might be one line. So you don't want to just do this one. Right here, 2 bytes is defined as 10. If I do the format also 10, it would be a problem. Even if I just multiply this one by 12 and that equal sign, let me just comment this line out. Control C. So then a way you format it, you do it programmatically. That way, all you have to do is change one element there, and then your format looks different. So if I do times 12, the equal sign, I didn't want to put like 12 equal sign here. That is too tedious to do that one. If you are doing a /tab, then you just do that one programmatically. You do 12 times that one. So that's much easier to do it. Some of you did it on your assignments there. I made some suggestion. Take those one as a kind of like, okay, yeah, I see the difference there. And starting coding in a much easier, don't repeat yourself. In computer science, DRY, DRY, it stands for don't repeat yourself. So you don't want to put 10 tabs here or 10 equal sign or 12 equal sign. you could do programmatically to just generate the same result. Notice if I do this one here, and then let's say I change it this one to a smaller digit, like 20 digit there, the first 20. I could run it and then say run it here. By the way, this one also finished with 1 million eventually. Before I run it now, you can see that it finished, and then it produced, and then the format was still good. So now if I just change it with these and then run it with only 2 of them, with only 2 of them, you can see the format is done, but notice this line is 1 line. I didn't want 1 line to be there, so this one, if I just do a smaller, like 2 bytes that I have there, that is smaller than the format, then that's good enough. So I could enable this one and get rid of this line out here. Now I will have the right spacing, because I wanted those ones to be different columns rather than one straight lines. So now it's columns 1, column 2, column 3. Each one of them is separated that way. And because I'm using the encore, then this one is in the center of it. Notice that I started with a even number. I did not put an odd number, because if you put an odd number, you don't divide it by equal numbers. So when you're using the encore, you're saying center it in the number of bytes here. 2 bytes is 16, so it centers it between 8 and then if it's 1 digit, it centers it starting at digit 9, and then that would go another and digit 8 actually, and then 8 digit on the right. If it is there space here, 7 digit on the right, like that, and because there's 2 digit printed here. So that is good enough for this one. Do you have any question for in terms of the format and or using the for statement, the range, or how we kind of print out these statements? And notice that here I'm using 2 tricks. One is putting the item first, the tuple, whatever I define on tuple here, and those are not going to change. It's read only. So I'm using those ones and print it as my header. So my header is constant there. I could have defined that one as kind of like other arrays, like a list or something, but lists are modifiable. So somebody could come in and change the wording there and assign my tuple or my list sub-zero to be something else, then they could modify it. But because I'm printing it, this is a good example of that information never changes. It's read-only kind of information as a header, so you could use the tuple as an example here. There's a lot of other reasons that you want to use tuple versus list, and one of the reason is that if the parameter that you're passing, it doesn't change, then you want to define it as a tuple. Next week, when I'm covering the next topic, maybe regular expression, I'm going to cover a module called subprocess, which is similar to OS modules, but a little bit more enhanced version of the OS, and it has more functionality in terms of using operating system kind of activity. With subprocesses, you could create a tuple and then just change it to a list and then execute the list in terms of more arguments. And those ones I'll show you the advantage of and the application of a tuple versus a list. So that way, when you're coding, if you don't want a hacker to say come in on your website through the internet, and then you may just be running an operating system command or reading a CGI script or to post or get method or put some kind of parameters to the database or do any kind of activity, so they cannot do some kind of SQL injection or cross-site scripting or modify a script by unintentionally, you're asking for the user to give their first name and last name. They give first name and last name, but they add some more kind of parameters to the array or list because you have a buffer overflow or options to read more parameters than you normally do. And then I'll tell you how to make your sites or reading those parameters with different data structure more secure so they cannot enforce their malicious code inside your code and run your code as if it is their code. I'll show you those ones, and you're welcome to ask question, and I will explain to each one of them depending on the things that we do at the time. Even though those are a lot intermediate and advanced courses, but covering it with the same data structure with my tuple or list or data dictionary, you want to know those things. The more you know it, the better. So that's as a kind of bonus things. I'm going to throw those kind of things every now and then at you so you can catch it up and learn it better. And if you feel like I'm good enough with this already and you don't want to discuss that one, let me know. I could just make sure that I cover it in the level that it's much easier for you to grab it. So it is 8:24. I'm done with the lecture for today, and then we have 6 more minutes to just